Hi, my name is Muhammad Syukur Roslan. I want to share about our introduction. Firstly, overview of selected GIS software. ArcGIS Pro. ArcGIS Pro is a professional desktop GIS software developed by S3. It is widely used for advanced spatial analysis, map production, and data management. ArcGIS Pro supports 2D and 3D mapping, geostatistical analysis, and integration with remote sensing data. It allows users to create high-quality maps and perform complex spatial modeling. However, it requires a paid license, which may limit accessibility for some users. QGIS, Quantum GIS. QGIS is a free and open source GIS software that provides strong capabilities for spatial data visualization, editing, and analysis. It supports multiple data formats and integrates well with other open source tools such as GraphGIS and Saga. QGIS is widely used in academic institutions due to its flexibility, active community support, and zero license costs, although its interface may be less polished than ArcGIS Pro. It is highly customizable and powerful. Secondly, overview of WebGIS platform. ArcGIS Online. ArcGIS Online is a cloud-based web GIS platform provided by S3 that allows users to store, visualize, analyze, and share spatial data online. It supports interactive web maps, dashboards, and web applications without requiring advanced programming skills. ArcGIS Online is commonly used for collaboration, real-time data sharing, and public map dissemination. Access is subscription-based, but often available through educational institutions. Leaflet. Leaflet is a lightweight open-source JavaScript library for creating interactive map webs. It is easy to use and suitable for beginners who want to develop simple web GIS applications. Leaflet works well with open data sources and other platforms such as OpenStreetMap, while it lets build in advanced analysis tools. It is highly extensible through plugins.
Hi, my name is Muhammad Ishraf bin Zulkifli and I want to share about technical demo. First, launching QGIS Desktop. QGIS Desktop is launched to prepare the GIS working environment. The software is used to manage spatial data, perform analysis, and create maps related to our study area. Second, QGIS interface and base map setup. After opening QGIS, the interface is displayed with a base map. The base map helps us understand the geographic location and provide spatial reference for further analysis. Interior layers such as countries and state boundaries are also prepared at this stage. Third, importing water production data from Excel. In this step, water production data downloaded in Microsoft Excel format is imported into QGIS. The non-spatial data is linked to spatial data, allowing us to analyze water production value according to different states. Next, attribute table for GIS analysis. This figure shows the attribute table that contains detailed water production data at the state level. The attribute table allows us to view, edit, and verify the data before it is used for mapping and analysis. Next, applying graduate symbology. Graduate symbology is applied to visualize water production levels using different color. Next, web-based map output using QGIS to web. Finally, the map is exported using the QGIS web plugin and displayed as a web-based map using Leaflet. This allows users to interact with maps online such as zooming and clicking on state to view water production information.
Hi, my name is Muhammad Danis bin Muhammad Izailan. My metric number is E24A3425. I will present the application to environmental or spatial problem that using GIS. First, a real world issue addressed using GIS. The issue was the flood. The flood caused by heavy rainfall, poor drainage and development near river, which complicate the evaluation and resource management. Next, I will explain how GIS tools were used to analyze and visualize the problem. First, collect the rainfall, river, and topography data using satellite. Next, map the area with high, medium, and low flood risk using spatial analysis. And lastly, create the visual map for evacuation planning and mitigation. It had improved early warning system, urban planning, and emergency management.
Hi, Assalamualaikum. My name is Muhammad Ifram bin Manas. My number match is E24B3379. Now I'm going to present about the comparison and evaluation between desktop GIS and web GIS by focusing the accessibility, usability, and the scalability. First, in terms of usability, desktop GIS is more complex and requires technical skills, but it offers very powerful tools for detailed spatial analysis. In contrast, WebGIS is more user-friendly and easy to use, especially for beginners, although it has limited advanced analysis features. And next, I'm going to talk about scalability. Desktop GIS depends heavily on the user computer hardware, which is make it less suitable and handling very large dataset or many users at the same time. On the other hand, WebGIS is cloud-based, so it can support multiple users and simultaneously and handle large amount of data. It can handling the large amount of data with more efficient. And next, in terms of accessibility, desktop GIS requires the software installation and is often expensive, which is limit access to certain users only. Meanwhile, the WebGIS can be accessed through a web browser from anywhere, making it more accessible and suitable for wider user. However, both systems have a limitation. Desktop.js is costly and has a steep learning curve, while WebGIS depends on internet connection and has security concerns. In the future, desktop.js be improved with better cloud integration, while WebGIS be enhanced by adding more advanced tools and offline access. In conclusion, desktop.js is more suitable for advanced analysis, while WebGIS is better for data sharing and accessibility. Alright, that's all from me. Thank you.
Now I'm gonna talk about digital skill that we use in this GIS project. First is layer organization and graduated symbology. For this map, I apply layer organization by placing the OpenStreetMap base map at the bottom, which provides geographic context such as coastline, cities, and borders. On top of this base map, I added the administrative boundary layer for Malaysia. This layering ensures that the background information supports the map without distracting from the main data. By arranging the layers in this order, the thematic information remains clear, easy to read, and visually dominant. I also use graduated symbology to represent the variation in data value across Malaysian states. Different shades of green are used, where lighter colors indicate lower values and darker colors indicate higher values. Based on the values range shown in the legend, this approach makes it easy to compare states and quickly identify areas with higher or lower values. Overall, the combination of proper layer organization and graduated symbology helps communicate spatial patterns clearly and effectively, making the map suitable for analysis and presentation. Second one is attribute table and data management, where all the data that provided by government were all put in this table, followed by state. In this case, we are focusing on area of forest reserved by each state. Third is quantile classification. The data is classified using the quantile method with 5 classes, meaning each class contains approximately the same number of features. The value range shown in the legend indicate how the forest area is grouped from the lowest to the highest values. By combining this classification method with an appropriate color ramp, the map allows easy comparison between regions and highlights areas with relatively high forest coverage, making the data clearer and more effective for visual interpretation during presentation. Lastly is where we use the plugin QGIS to Web to publish the web-based map. And here is the result that's shown in the QGIS to Web.
This is final result for all members. First, Muhammad Irfan chose the state of Terengganu. Next, Muhammad Dennis selected the state of Kelantan. After that, Muhammad Shukri chose the state of Sarawak. Muhammad Israf selected the state of Pahang. And lastly, Adi Saikal chose the state of Johor. Lastly, for the conclusion, Geographic Information System (GIS) are essential tools for managing, analyzing, and visualizing spatial data in a systematic and meaningful way. By integrating geographic location data with attribute information, GIS allows users to identify spatial patterns, relationships, and trends that may not be easily understood through traditional data analysis methods. The ability of GIS to convert complex datasets into clear maps and visual outputs greatly enhances understanding and communication of graphic information. Furthermore, the development of GIS technologies such as WebGIS, cloud-based platforms, and real-time data integration has increased accessibility and collaboration among users. Tools like ArcGIS Online and open source software such as QGIS allow students, researchers, and organizations to analyze spatial data without high costs. As a result, GIS continues to evolve as a vital technology that supports innovation, planning, and sustainable development. Overall, GIS plays a crucial role in addressing real-world challenges by improving data analysis, visualization, and decision-making process.